In this lesson, we'll look at special quadrilaterals that have been transposed onto a coordinate plane. In this question, we're given a parallelogram and we're given 3 of its 4 vertices. We have 0, 8 for point B, 5, 6 for point C, 0, 0 for point A, and we're asked to find the coordinates of point D along with the perimeter of the total parallelogram. So let's first find the coordinates of point D. We're looking for an x value here, so we want to know what this x value is. And we're also looking for this y value here, right here on our coordinate system. If we focus on some of the other vertices, we might be able to find this x and y value. Let's see, if we look straight above point D, we see point C. To get to point C, we went from the origin over 5 units and up 6 units. So this value on the x-axis has to be a 5. So that gives us our x value for D. Now all we need is the y value. Unfortunately, we don't have a point to the left or right of D to help us find our y coordinate, but we do know that parallelograms have opposite, parallel, and congruent sides. So we can use the slope of side BC to find the y coordinate of D. Using rise over run, to get from point B to point C, we will rise a negative 2 units and we'll run a positive 5 units. So for a minute, take a look at what we've done here. We've gone from a y value of 8 to a y value of 6. That's where our negative 2 comes from. And then we've gone from an x value of 0 to an x value of 5. So that's where our plus 5 comes from. Let's do the same thing starting at point A and moving to point D and see what that gives us. If we rise a negative 2 units and run a positive 5 units, we're going to get the coordinates 5, negative 2. We already had the 5 here, and now we can add the negative 2 to our coordinate. So we started at 0 and dropped 2 units. That's where the negative 2 came from for our y coordinate. And we already had the 5. And if we didn't have the 5, we would have been adding 0 and positive 5 to get the 5. So there was more than one way to get this coordinate. So the answer to the first part of the question is the coordinates of point D are 5, negative 2. Now let's see if we can figure out the perimeter of this shape. First, let me clean up the graph, and then we'll make some new marks on here. The easiest lengths to get are any horizontal or vertical lines. We don't have any horizontal lines here, but we do have 2 vertical lines. We have from point B to point A, 8 units. And we know that by subtracting the y values, 8 minus 0, and getting a total of 8 units. We also know that all parallelograms have congruent sides. So not only are the opposite sides parallel, but they're also equal in length. So we can put another 8 here. Because sides BC and AD are not horizontal lines and they're not vertical lines, we need to use the Pythagorean theorem or the distance formula. Let's take a look at the right triangle made right here. We have a leg length of 5 units, and I'm getting that from D's coordinate here. We went over 5 units to get directly above D, and then we dropped 2 units, so I know the leg length here is going to be 2. Using the Pythagorean theorem to find the length of the hypotenuse, we'll have c squared equals 5 squared plus 2 squared, or c equals the square root of 25 plus 4, or c is approximately equal to 5.4 units. So let's put that over here on our graph. We've got that segment or side AD is going to equal 5.4 units, and we know that the opposite parallel side has to have the same measure of 5.4 units. So all that's left to get the perimeter is just adding the 4 sides together. That's going to give us 8 plus 8 plus 5.4 plus 5.4, or 26.8 units for a perimeter. Now you know a bit more about special quadrilaterals on the coordinate plane. See you next time.